Hello and welcome. This is the first of 3 videos that we are creating on the role that artificial intelligence is now playing on literacy and learning.
And we've started with this rather lovely quote from Gabriela Garcia Marquez, where, this feels like the world's being reinvented. We're reinventing themselves, but the time of cholera was also a time in his novel, a time of chaos and a time of anxiety. So we're in this strange world that's being reinvented, this world of AI, but also the world around us sometimes feels as if it's moving so fast that it's kind of on the edge of chaos. So in the time of, we've taken a little riff from the title of this novel.
So the first video of the 3 that you'll be viewing is of course about the disruption that AI has caused. Then we're going to actually go into an example we have of how we harness, tame and use AI for ethical and productive purposes in education. And then we're going to go to the last video, which will explore what the imperatives and the implications of AI for the future of learning. So, learning in our time, learning and media. This slide is sort of truncated in terms of the timeline. However, what it's trying to say is that for most of human history, we made meaning in multiple ways, mostly with oracy, but also with images, with symbols, with markings on our bodies, on the earth. Meaning making for most of human history was synesthetic and elaborate. Then here comes the printing press, and you can see truncated together there is higher education and school learning, which now becomes focused not on listening or apprenticeship, but on the book. The book becomes, the text becomes the golden tool that universities use, that schools use, in order to organize the way knowledge is created and disseminated. But, I want you to know that it hasn't been a long time, maybe 800 to 1,000 years for the higher education system and less for the school system. Yet all of us have grown up in this moment where we value these traditional ways, the textbook, the lecture, writing in response, the test, all these artifacts that have come up around traditional schooling since the invention of the printing press and the book. More recently, though, of course, we've been talking about the digital and the way in which digital has impacted on literacy and learning. We didn't quite anticipate how far it would go, and right now we have this explosion into artificial intelligence. But I'd like to point out that artificial intelligence did not come out of the academy. It wasn't the professors and the teachers who invented artificial intelligence with digital tools. It was, 6 men in America, 2 in China, 1 in France, who scraped all the work that was produced, in text form, in any language across the world. They scraped it all together, put it in the large language models, and are now selling it back to us. And we as educators are wondering, what do we do with it? How do we integrate it? What does it mean? What does it mean for learners? What does it mean for us? What do we need to learn in order to harness it in effective and ethical ways? That's the dilemma we're facing now upon us, and that's why we're going to talk first about the disruption AI has created. But I want to point out that the textbook and the book had its own limits and dangers as well, because it was controlled by individuals. It was hard to publish or get in, or there were some words which were deemed better than other words. So that period has its own constraints about authorship, content, what was appropriate, and who was able to participate in that textual world and who isn't. Now, all that's been blown open by the way in which AI has scraped everything that any human in any language has produced.
So I'm going to start trying to explore a little bit about what AI is and how it works. So in the history of the internet, we had Web 1, which was sort of web brochures, essentially, which is information being transmitted. Then Web 2, Web 2.0, which is what's often called, was kind of social media, where people began to participate and act on a mass basis on the internet. In a way, this is kind of like a third phase now. It's not called that. Sometimes it is, but mostly it's not. It's really a new phase where not only are you using the internet to do all these everyday things like banking and emails and talking to each other, but these are systems which are constantly learning about you. And so these are actually learning systems. They're systems where you're involved, but the intelligence of the system in relation to you is what it's learned about you along the way. So, for example, if you're on TikTok and you're scrolling your way through, TikTok learns which bits you've lingered on. If you're on Facebook, you've liked something. If you're sending emails, you can rest assured that if it's Gmail, Google is building a pretty comprehensive profile of who you are. Search, every time you search, the system gets to know you more by what you search. And of course, their main motive is to send you advertisements, but nevertheless, part of the effectiveness of these systems now is the fact that they are learning systems. So we as educators really have a big responsibility to understand these evolving technologies, because we're learning human beings, but these are learning machines.
And there's a lot of anxiety about that learning. Even, you have it on your hand now, a watch that knows everything about your body and what you've done, whether you've walked or not walked, etc. So it's ubiquitous. The capacity to learn things about us through the new AI interfaces is just mind-blowing, really.
But this new AI universe, this new universe of learning machines, has recently, when I say recently, in the last 3 years essentially, with the emergence of generative AI, and we first discovered generative AI en masse with ChatGPT at the end of 2022, I mean. So it's produced a problem for education. So the problem is that it will write your essay for you, it'll answer your question for you, it'll do all the things that we historically regarded as evidence of your learning, right? So, it's very easy to just simply put in a prompt and off you go, and the essay's written, put in a question, there's the answer. So what people have tried to do here is they've tried to build ways of detecting this. So, there are all these AI detectors around at the moment, which are becoming kind of better all the time. It's a kind of a cat and mouse game here. And the cat and mouse games are kind of a losing game in a way, because every time an AI detector seems to half work, here are these pieces of software. There's 3 of them here there's lots of them actually, but there's just 3 that we've given an example of here, where you can humanize the text, which will, all the markings of it being AI will be wiped out, all the distinctive ways that AI speaks. But in any event, the main AIs are becoming much more human in the way the first time when we 2023, when we started these things, they sounded pretty wooden and robot-like. They're getting more and more human themselves. So no matter how hard you work on the detection game, it's not one that you're going to solve easily. There's an English academic by the name of Mike Sharples. He came up with this rather ironic, funny concept, which is democratizing cheating. And what the estimates are, which he quoted in his paper, was that up to 15% of essays handed in US universities were written in paper mills. Paper mills are, you pay somebody $100 and they'll write the paper for you. Well, now it's much cheaper, and he calls this democratizing cheating. So what do we do? Now, we have a solution, and we're going to actually give you the solution, a definitive solution, and the problem's all over in the next slide. There's our solution, right, which is, and look, this is kind of not a joke. We've got colleagues here in the university who are going back to what's called the blue books. And the blue books are these little thin books with a blue cover where you sit in a room and it's heavily proctored. There are people watching to make sure you don't cheat, and they're looking over your shoulder to make sure that you're not, you leave your phone outside the door, there's no computers, no nothing. Okay, now, there are a couple of problems here. I want to ask you a rhetorical question. And the rhetorical question is, what's the implicit theory of learning that's going on in this slide? What's the underlying theory of learning? Well, I'll answer the question. It's that learning is individual long-term memory. And what's the definition of long-term memory? It's until the day after the exam. So, here we are in the 21st century when we've got these cognitive prostheses, that's what Mary and I call them, these phones in our pocket and these computers and tablets and all those kind of things, where we actually have much more to remember than's realistic to remember, but also we become more reliant on them as these extensions of our cognitive selves, if you like, if you want to put it that way. So, this is
many of us, Bill, have forgotten the skills of remembering, forgotten telephone numbers or routes to certain places, because we've de-skilled in some areas as we've skilled up in other areas using these new devices and tools that are available to us. So there's a shift in habits and practices.
There's also just much more to know. I mean, if a doctor's walking around on their rounds, can they remember everything they need to know? Well, maybe they've got a tablet with them where they can look stuff up. There's just so much to know these days that to actually value individual long-term memory is kind of anachronistic. It probably wasn't a great idea ever, to be quite frank, to make that the main focus of education, but this slide tells you that it was. Now, there's a second problem here with the Blue Books. The second problem is we've been typing on computers since the 1980s. Working on a computer involves a certain kind of methodicalness where you do something roughly, you go back, you read it again, you change things. And in fact, handwriting is very resistant to the kinds of corrections and the kinds of methodical writing we've become used to. Our writing habits have become much different. And actually, in a way, much better, because we're constantly correcting things. Now, you can scribble things out and draw a line through it and put a little mark with a extra word, but there's a limit to how much you can do that before the darn thing becomes completely unreadable. So not only is this kind of anachronistic. Oh, and by the way, in what workplace now is extended handwriting of any need or value? It's not. So in every sense, this is a terrible idea, and it's more terrible by the day.
So this is just a hint of the kind of disruption that's out there that's creating all sorts of challenges for us as educators, and of course challenges for learners too, who are very like ducks to water to the new technology. Even little babies are instantly scrolling and moving around in these spaces. And it's a very different world from the mechanical production of knowledge that books and texts were involved in. We've shifted from that dramatically.
Okay, so we're going to go back and do a little history of the technologies of represented meaning, or the technologies of written text. So in the next slide,
I want to say that books still matter. I mean, we don't want to appear as though it's one way. We always talk about tools as repertoires of tools, different tools for different purposes. So we're just historically saying what the shift and disruption is about, rather than saying that books no longer have value.
So let's go back through the history of books now. So here's a revolutionary technology. The movable type, invented by Pi Xing in China in the 11th century, didn't become generalised, but in fact much the same idea gets reinvented, or maybe he learnt something from the Chinese, goodness only knows, or knew something of the Chinese invention. Unlikely actually, because it's 4 or 5 centuries apart, but it doesn't matter. Johannes Gutenberg in 1450 builds the printing press. Now, the important thing about the printing press, and what's revolutionary about it, is the mechanical reproduction of text. And as Mary said earlier in this becomes the basis of modern schooling. The fact you can print textbooks, the fact that learning to read and write becomes important because so much is printed to be read, right? So it becomes a kind of a world-changing technology. And by the 19th century, it became something where mass institutionalized schooling regarded print literacy and learning to read and write as a very essential part of life.
And knowledge was funneled to you in the university through the lecture and into schools through textbooks and instruction. It was controlled, it was selected, it was directed to you by somebody outside of yourself.
Now this is a big change. Now we have a machine that actually makes meaningful text. And in a way, humans can do this, and we'll kind of go into this in a bit more detail over the next few slides. But generative AI can do something, which is what we do is we put words together, and there are endless combinatorial possibilities in language. There's a pile of words, and there's syntax by means of which we put words together. And the old printing press just simply did as it was told, you know, whatever was programmed into it, it reproduced. This actually produces meaningful text in a way which is much like humans. But the most important thing that the point we want to make here is that the generative AI does that in a fundamentally different way from the way humans do it. Now, this is big. This is the first machine to do something along these lines. What are the consequences? Well, we're going to try and dig into the how and the consequences in the next few slides. Let me say something about this image. This is generated by generative AI. We told it, you know, create something like a Greek icon which is looking to the future and talking about Unicode. We're going to explain Unicode in a moment. So there's some Unicode characters, and But what's kind of interesting about this is that it was a textual prompt that produced this image. But nevertheless, the most important part about generative AI is that it's primarily textually bound, but also there are these other kinds of AI which are associated, including image generation, video generation, all kinds of generation going on at the moment, which have flowed consequently to the original invention. Now, what I want to mention for a moment is human meaning, human sentence making. And this is a rough version of Chomsky. There's Chomsky, the famous linguist. That what we have in a sentence is we have nouns and we have verbs, and we put them together into certain structures which are relatively regular. But we can have an infinite number of nouns, an infinite number of verbs, and what every human being does all the time is restate the world in a way that's never been stated before. So the last 300 words I said have never been said before. If you've got a small child with you, a 3 or 4 year old who's talking, the last 300 words they said have never been said in that order before. So what we do as human beings is we don't repeat the meanings in language, we remake the meanings in language in some really profound kinds of ways. This is a quote from Chomsky from his famous foundational book back in 1957, Syntactic Structures. Now, moving forward to Chomsky now. Chomsky, late in his life, co-authored an article in the New York Times where he said, look, this generative AI is just parroting what human beings say. It's just a machine that repeats things. It's nothing fantastic, nothing important. It's just a machine of repetition. This article down in the left-hand corner there is a very important article written by Emily Bender and a couple of other colleagues, including Tim Jabrou, who at the time, well, maybe a bit before this, worked at Google, and he's no longer at Google. And they're just saying, look, really what these are stochastic parrots. They're just statistical machines that parrot human experience. Now, one of the things is Mary and I kind of argue about this a fair bit. You know, I say, look, actually, this is not true. They're building new meanings in ways which are kind of slightly unnerving, slightly problematic, but these are new meanings, and that's pretty revolutionary. Now, Mary and I have a kind of an argument we make about this, and I'm going to get her to say what she thinks about this, and then I'll come back and say a little bit more about the third quote that we have there.
Well, I still think it's a bag of words. I think that was one.
Oh, sorry, I didn't say bag of words, so I was going to leave that till later. Oh, okay. So sorry, I'll have to mention the third one because I haven't. The third one's about a bag of words.
Well, I can't talk about it without. All right.
Okay, I'll go on to the third one.
Yeah.
Before Mary says anything.
Yeah.
Right. Okay. And the third quote here is actually a quote from Noam Chomsky's advisor when he was doing his PhD at the University of Pennsylvania, whose name was Zelig Harris. And Zelig Harris coined a very famous phrase, and that was the phrase bag of words. Now, all the natural language processing people, a lot of people who've been dealing with computers and language for a long time say, oh, look, all we do is regard language as a bag of words, and then we, connect statistically one word to another. We just mush them all up in the bag and we connect them all together statistically, and in a way the meaning's irrelevant because all we're doing is mucking around with a bag of words. Well, in fact, if you go back to that original paper from 1954, what Zelig Harris says is, Zelig Harris says language is not just a bag of words, it has a distributional structure. In other words, it has meanings which are quite structured in the way in which those words are arranged. It can never be considered as just a bag of words. So, my argument is we've now got a machine that, it might be a bag of words that it's got, but it doesn't treat them as a bag of words. It treats them in the way it does coherently because it actually has built a map of those distributional structures. Right. So my argument is, just to kind of summarise what Mary's about to disagree with, my argument is this is a pretty remarkable machine that can do human meaning in these ways.
I don't disagree that it's remarkable, but those patterns are because they're in the text that they're scraped and stolen. It's dangerous to assume that these machines are going to be able to have an independent way of making meaning in the world. There are hundreds and thousands of people fine-tuning these different large language models, depending on what the owner wants them to do or not do, and including when you move to social media, where it's Facebook or TikTok or whatever, behind the way in which these artificial intelligence meaning-making tools operate are human, or a lot of humans, determining the algorithm, determining and fine-tuning how it's going to be reproduced. And I think it's important we keep saying that, because as educators, it puts the onus on us to become involved as humans in the shaping, taming, taking on, refining, insisting that some things have to happen, whether it's regulations in terms of what children can access. We can't take the human out of it, no matter how far it goes, even if some human prepares or fine-tunes a machine to say, at some point after these three things happen, you can explode or, attack us. It's still a human doing that.
My response to this is, it's unbelievable that there's a machine that does it relatively autonomously from humans. Humans have created this darn machine, but then the machine does it. Yeah. This is pretty amazing.
Bill, a washing machine, it has many cycles and many, like it's programmed. So you can choose, for towels, or you can choose for... It's programmed by humans across many dimensions. And this is the same. The programming by humans really, really matters. And there are machines who do multiple things as a consequence of that design and that fine-tuning. And this is just a more elaborate version, and a version that's taken over in powerful ways, including responding to us as if it was human, because it's been fine-tuned to be nice to us, to be polite to us, to encourage us to stay in the space, fine-tuned to fool us into thinking we're having a relationship with a chatbot, or fool us into thinking that it respects our questions and knowledge, when it's been fine-tuned to do that in order that you continue using it.
So I'm going to go back now and backtrack and try to unpack a little bit about AI itself and AI's history. And in a way, there have been three quite fundamental paradigm shifts in the history of AI. The first era of AI, which really begins from the beginning of computing in a way, because these are machines that do intelligent things artificially, they're machines, was symbolic and rule-based AI. A good example of that is Plato. I'm giving educational examples here, by the way, just because we're talking about education. Plato was invented here at the University of Illinois, and it was the project began in 1959, and in fact ran through right until the 1970s until personal computers arrived. So what Plato was an electronic learning environment, and Mary and I have written an article about this, a long version of the story, which we'd encourage you to read. We've referenced it there on the slide. So, it was something where it was programmed learning in every sense. It learned about you, the learner, because the data the answers you gave to questions and whatever you did, it was tracking all of that in a way that no teacher ever could. So it was learning about you. It was classical. It was, very much like artificial intelligence in that definition, in that sense. And here we are from 1959 on. Now, what happened was by the, in terms of this as an overall system of, artificial intelligence system, these systems are very brittle. They can't deal with exceptions. They can't deal with real-world complexity. And at a certain point, there was a crisis where these things became overburdened and were kind of not working. That's the short version of a much longer story. And this was called the AI winter. Then there was a kind of a revival of AI around data-driven systems. And again, I'm going to simply give an example from education, natural language processing. So what we did there in automatic writing evaluation is a set of human evaluators were given, there were 400 or 500 texts, and they gave them an A or a B or a C or a D, and then simply by the statistical comparison of just the bag of words, when the next essay came in, it was able to give it an A, B, C or D by statistical comparison with the corpus that was already there. So that's data-driven AI, in which there were two kinds of machine learning: supervised, where people labelled the essay as an A or a B or a C or a D, and unsupervised, where the machine found patterns in the data and asked the human to label them. But then what happens, and I mentioned the year 2017 before, was a very important article, Vaswani et al. 2017. They invent this transformer architecture. It was a group of 8 researchers at Google that published the article back in 2017, so it's not that long ago really. Our argument is this is a fundamental paradigm shift. Is what it does, it leverages the semantics of language to run AI. And we're going to try to explain how it does that in the slides that follow. In order to kind of try and work out what these machines do, I want to compare them with what humans do. So found designs. In the world we've heard a lot of speaking, we've learned to read, we've got images, we've got all sorts of stuff which are part of our world, which are the meaning resources that we've learned to use. But when we do design work, which is when we speak, or when we draw a picture, or when we write something, we recombine those things in a way that's never been done in the past. That was the point I mentioned before when we were talking about Chomsky. And what that does is that produces about designed artifacts. So what happens when we think of literacy, for example, in schools? We think, learning the correct spelling, learning genres, doing things right, doing it the right way, as if what we do is reproduce. Actually, what we do is we do design work which constantly changes the world. Now, this is actually what these darned GPTs do as well. They actually take found objects, which is this huge corpus they've taken. They do design work on that, which is they reprocess that based on a prompt, and they produce a designed artifact which is totally meaningful, totally coherent, and unique, that's never been produced before. So this is the sense in which they're like human beings.
Except, and I have to add this, that in each one of these stages, yes, they have the found objects, but in the designing phase, they are fine-tuned to do that. They don't do it automatically by themselves as if they had their own mind. It's being framed up to create those new artifacts as a consequence of the fine-tuning and the algorithm that they're involved with. So it's not right to saying that they're the same as the human process of designing and the redesigned.
Right. The effects are the same though. That's part of what I'm saying, is the effects are the same, but you're absolutely right, the mechanisms are completely different. That's what we'll go on to and talk about now.
The effects aren't exactly the same because we're suspicious about the redesigned, and that's what's causing all the anxieties at the moment. Sometimes it's superior to what a particular human might have produced, and sometimes it's inferior. Right. So we're right here at this moment arguing about what comes out of this process when machines do it. We argue about it when humans do it too, but more so. The anxiety and skepticism is greater. We have to figure out how we understand it.
All right. How do these things work? Well, at the end of the day, these are binary notation machines. So what we do is meaningful stuff goes in, everything gets reduced to binary notation, which is you write it down in zeros and ones, and meaningful stuff comes out. Now we want to try and work out how it does that and what the effect is to this remarkable machine that writes stuff. How does it do it? Firstly, binary notation. So firstly, it writes down the names of things. This is before it even calculates. So it writes down the names of things in binary notation. Secondly, it can calculate the number of those things in base 2, because binary notation only allows you to do it in base 2. And thirdly, it can do certain forms of very elementary logic, Boolean logic, which of course you can build elaborate layers and layers and layers on top of that, but essentially down the bottom it's just a if-then, yes-no kind of logic. Now I want to talk now specifically about the text semantic AI part in relation to this binary notation machine. So firstly, what we start with in written language is we start with graphemes. Graphemes are things we've written down, characters if you like. And those characters, there are two kinds of characters: phonemes, which represents a sound, like the letter A, for example, or ideographs, like the number 8. Ideograph represents an idea. Generative AI cannot work and doesn't work in phonemes. It works in morphemes, which are groups of letters which become a word. So, for example, the word walk, W-A-L-K, is a single unit. These things then in the generative AI become tokens. Now, there's a set of compression mechanisms which they use, so the cacophony of letters in the world, statistically things hang together as morphemes. There's just a statistical reason why the system lands on morphemes to do with its own compression mechanism, but it lands on morphemes nevertheless, and ideographs, both as tokens, both as signs of meaning. Now, it starts with the graphemes, though, with this universal scripting language, Unicode, 150 or 1,000 odd characters, so every piece of digital text, everything in every computer can all be represented in Unicode. So when you do a letter or an emoji in one font and on one device, and it goes to another one in another font and looks slightly different, the emoji, it's because there's an underlying set of representations which travel between one device and the next. That's Unicode. Now, this is a point where we can also define text. What do we mean by text? Anything that can be written in Unicode. That's our definition essentially, which also includes math and code. Obviously, they can be written in Unicode. Now let's parse a sentence. Here's a sentence: I walked to work. So that word walked is actually two tokens, because walk is something you do, and ed indicates that it's in the past tense. Now what we would do in school grammar is we would say that's past tense, and there's a subject and there's a predicate, and that's the verb, and to work, to is a preposition, work. So we would do a kind of elementary parsing of that sentence. Here's another sentence now, which is I walk the dog. Now it actually looks like it's the same thing, because we've still got walk and it's still walked in the past tense. But in fact, it's a very different kind of walking. Walking to work is A to B. Walking the dog is A back to A, and probably the dog straining the leash, and you're doing it for the dog's sake, or maybe your own as well. But it's a different kind of walking with a different kind of intent, a different kind of purpose, different kind of sentence. Actually, that means I walk the prisoners to their cell. Well, again, it looks like the same word, but in fact, it's a different kind of walking, which is they're being walked against their will. So what we do in school grammar is we do a relatively simple grammar. If you're a grammarian, though, you can look at case and voice and mood and all these other elaborate concepts, and you can parse out those different types of walk in different sentences. You could do that. Now, in fact, we don't. But as humans, we have an instinctive sense of those different kinds of walk. we you know, the semantic character of those things we know, even if we don't have an elaborate grammatical language to talk about it. But in fact, our brains are working on a kind of grammar where we're able to substitute things out from one to another and make sense of them. Now, one of the things about generative AI, though, is that it simply does this on statistical relations. So there's millions of tokens and trillions of vectors. The vector's the relationship between tokens and each other. There's probability of one word being near another word, and it does it without any grammar. It's this huge empirical machine. And this is, Mary and I, you know, the work that we do is very much based on the theories of Michael Halliday. And what Halliday says is that a grammar, if you like, is a theory of everyday life. So let's go back to Chomsky with the nouns and the verbs and the sentences. You know, you have nouns which are things, you have verbs which are actions, you put them together and it's a meaning. And that is actually a theory of the world. The world has things and actions, and we put them together every day in our sentences. So in fact, we have that kind of theory, but generative AI has no theory at all and no mechanisms for making meaning. It's just simply about the statistical relationships of words with each other.
But I think we want to end up on the main point we want to make, that yes, meaning is made by these large language models in particular way, but humans make meanings in other ways. You can say that you could go into a library, for example, a brick and mortar library. It had all the text there, perhaps a large library, visuals, audio, whatever. And you could choose whatever you want, take it home, read it, return it. But in the AI environment, what you choose is what the machine learns about you in order to send you more information about that same thing. So that is a very powerful difference. And also, the AI environment, as I said right at the beginning, is owned by a handful of people, and they use thousands of people to fine-tune the way in which you receive knowledge from their large language models, and the way in which they end up in social media spaces, the platforms, is controlled again by the algorithms that the owners decide matter. So it's a very different political and social relationship in the AI environment. It's not just simply a space where meanings are made. They're negotiated not evenly and not fairly. Your use creates an impact because the owners want you to stay in these spaces for other purposes, but it's not the same at all. The meaning making in these contexts is controlled by the owners, and you have to control it by the prompts that you put in there in order to get what you want. Whereas for human beings, you know, we live in environments which are physical and emotional and social. We interact with each other. We are able to create meanings from those interactions, and we genuinely have to negotiate meaning human to human as we reproduce whatever knowledge we want to make. These are two different ways of creating knowledge and receiving knowledge, and we have to be very clear about the power of both. Yes, we have to harness and understand the value of artificial intelligence, the large language models, for what we want to do as humans, but we have to realize the constraints and dangers and purposes that are very complicated in the AI environment, as they are in the human environment. But in the human environment, you get to argue and negotiate face-to-face or in much more intimate kinds of ways as meaning is created and circulates. Just to sum up, AI is essentially statistical and empirical meaning making, whereas human meaning making is theoretical and grammatical.